Today we're going to cover 17.3, the area between a curve and a line. So far what we have found is we have calculated the area of a region between a curve and an axis, be it the x-axis where you integrate with respect to x, or the y-axis where you integrate with respect to y. So today we're going to find the area between a curve and a line other than the axis. Okay, so for example, okay, what we're talking about here is this. So what we have in this question is we're trying to find this what I call shaded region over here. So the main concept here that we need to do is first we integrate the curve with respect to x, so we can find this whole chunk here. Okay, then what we do is we find the area of this rectangle here. Then what we will do is we take the area of the entire chunk, okay, minus away the area of the rectangle. What we'll have left is the area bounded by the curve and the line in this case. Okay, so now, okay, what we're going to do here is this. First and foremost, what I need to do is to find the coordinates, the x-coordinates rather, of A and B itself. So now what I'll do here is I will solve simultaneously. So y equals to 4 plus 5x minus x squared, and y equals to 8. So I can take equation 1 and equation 2. This will help me to find the coordinates of A and B, the x coordinates rather. So I'll just take equation 1 equals to equation 2. 8 equals to 4 plus 5x minus x squared. Then what we can do once we simplify, we get x squared minus 5x plus 4 equals to 0. Simple factorization should yield -4, -1. So x equals to 1 or x equals to 4. So on the diagram itself, what this shows is here, this is 1, okay, and this is 4. So x equals to 1 is the for A, and x equals to 4 is the coordinate of the x coordinate of B. Okay, so now as I've explained, first and foremost what I need to do is to find the area bounded by the curve 4 plus 5x minus x squared and the x-axis. So what I do is I'll integrate. Limits are 1 to 4. 4 plus 5x minus x squared with respect to x. So what I get is 4x plus 5 over to x squared minus 1/3 x cubed. The limits are 4 to 1. Okay, so then what I will do here is this. If you do everything correctly, okay, so what you should get here is 26.5, okay, if I'm not wrong. Okay, it's 28.5. So what you get is 28.5 units square. Okay, if you did everything correctly. Now what we have here is to find area of rectangle. So area of the rectangle itself is equals to, okay, if you see, all right, this breadth is 3 units, this height is 8 units, hence the area of rectangle is equals to 8 by 3 is equals to 24 units square. Hence the area, okay, of shaded region will yield 28.5 area bounded by the curve and the x-axis minus the area of that rectangle over there. What we get is 4.5 units square. Okay, so now what you can do is you pause the video. Please try 13. Very same concept. Okay, you find the area bounded by the curve and between the limits of the x-coordinate of P and Q, minus away the area of the rectangle. What you get right is the area of the shaded region. So pause the video now and you're ready. Unpause and I will carry on with the explanation. Okay, so what happens here is this. First and foremost, since this is the line y equals to 7, if you substitute this into the curve itself, okay, 8x minus x squared, what we can find is the x coordinate of P and Q, which is 1 and 7. So if you look, right, this is 1, this x coordinate is 7 itself. Then what they have done here is they have integrated 8x minus x squared with respect to x. So this will actually give me the area bounded by the curve. Then they also integrated the from 1 to 7, 7. Either you can do this, or the alternative to this portion here is simply to find the area of rectangle. So the area of rectangle in this case, if you notice, the breadth is 6, the height is 7. 7 times 6 is equals to 42 units square. Okay, so what they have done here is they integrated, they put in the all the values. Your final value should give you 36 units square. Okay, and that concludes part 1 of 17.3.